All right, good. Okay, good afternoon. I hope y'all had a really good lunch. I am Leslie Brooks, and I am the BDD coach. And we're going to talk today about the future is finding zero bugs in QA. So that's not our world today. Boss? Oh, I'm sorry. Yes, indeed. Wow, okay. That's not our world today. Thank you, boss. If any of y'all have questions or don't understand something, please interrupt and we will have plenty of time for questions. So today, our world is that we write requirements and we expect the code to have bugs when the developers write it. And hang on just a second, let me get this out of the way. And we expect the QA team to miss some of the bugs, and we expect the customers to find some of those bugs. And nobody likes this, but
yeah, lucky.
There's not really anything we can do about it. Nobody sees a way out of this. So so why do we write requirements? Let's talk about methodology and how we do things today. Why do we write requirements? Well, we write requirements so that the developers will understand what the customer wants, but this doesn't always work. The product owner writes the requirements and says, this is what the customer wants. And the developers read those requirements and say, okay, I understand. This is what the customer wants. That's what I need to develop. I see some heads nodding. And QA reads that and says, okay, I understand. This is what the customer wants. This is what I'm supposed to test. And now we have bugs. I like to group bugs into two categories. There are little b bugs. Little b bugs look like this. These are the ones where the code does not do what the developer intended. So the text entry box isn't large enough, or the database field is the wrong type, or under some circumstances, the shipping costs aren't added. And they may hide for quite a while, but when you find them, they're generally not difficult to fix. Big B bugs. Big B bugs, you don't want those. These are the ones where the code does exactly what the developer intended. It's just not what the customer wants. And these can be very, very costly because the entire development team may have spent 2 or 3 sprints writing really, really good, high quality, maintainable code that you can now throw away because it doesn't do what the customer wants. And our current agile methodologies make all of this far too easy. Traditional narrative requirements are much too easy to misunderstand. The developers think they understand them, but they don't. And so we have big B bugs. And with our current agile methodologies, we assume that we have to write test cases to catch those bugs. And if we have test cases, we have to have a QA team to run those test cases. And our test cases aren't going to be complete, and they may have problems of their own. So we have to have a bug tracker to keep track of the bugs that escape from QA into production. So our current methodologies will not solve this problem. But specification by example is an agile methodology that is designed to fix all of these problems. It invalidates all of those assumptions that we just talked about. SBE is a better name for BDD, behavior-driven development. Behavior-driven development doesn't tell us what we're doing, but whatever it is we're doing, it's the developers doing it. Specification by example says that we are writing requirements that include examples. And that is where this methodology begins. And with it, we really truly can find 0 bugs in QA. And before you tell me that I am smoking really good stuff, let's look at what SBE has been documented to do. So BNP Paribas is a large French multinational bank. They had a good, solid, agile development methodology, and they had really good metrics of what their developers spent their time doing. That's why I like this case study, because you can find it easily online. They had really good metrics, which none of my clients ever have. And I had nothing to do with this. So they were spending 35% of their time fixing bugs, which I think is very typical. 30 to 40% of a development team's time is spent fixing defects. And they brought in a consultant who introduced specification by example and TDD, test-driven development, where the developers write their unit tests before they write the code. And that's a very good practice. It has a smaller scope and a smaller impact than specification by example. 9 months later, their developers were spending 4% of their time fixing defects. And if they were only spending 4% of their time fixing defects, they were also creating far fewer defects. So specification by example is definitely not magic. And it is definitely not take a 3-day course and become an expert. It took BNP Paribas 9 months. It takes time, it takes practice, it takes discipline, and it is a whole team methodology, but it absolutely can work. But if you don't include the product owners, whoever writes requirements in your company, then it will not work nearly as well as it should. The name specifications by example, specification, requirements, that's where it begins. It's a methodology. At Raytheon, I introduced SBE in a data science group. They did not have good metrics, but once they were trained and coached and up to speed, and that took months, over the next year, they went to a regular 2-sprint release cadence. Every 4 weeks, they put out a release like clockwork. And in a year, they delivered 2 bugs into QA. That's not 2 bugs to production after QA found 200. That is the developers delivering 2 bugs into QA. So how can SBE possibly invalidate all of those assumptions that we talked about that all of us take for granted? I mean, that's the way the world is. Well, SBE says that requirements must include concrete examples because that makes them much, much easier to understand and much more difficult to misunderstand. And SBE says that we don't need test cases because the requirements are the test cases. There are no separate test cases to write. And if the requirements are identically the test cases, then the test cases cannot have errors unless the requirements have errors. We had that situation at Raytheon. The data scientist came to us after a release and said, oh, it's got a bug. And we were like, bug? All of the requirements pass. Please show us this bug. And they showed us, they said, well, if you have these inputs, then you do this calculation and this is the output and that's wrong. And we said, this is what the requirement says. And they looked at the requirement and they went, oh, we wrote the requirement wrong. We will be more careful next time. So they wrote the wrong requirement and we delivered the wrong code. And we can only have missing test cases if we have missing requirements. And specification by example, when you list concrete examples in the requirements, it makes it so much easier to see missing examples, therefore missing requirements. And specification by example makes it possible for us to deliver test automation in sprint before the developers finish writing the code. So if you can deliver the automation in sprint, then you can change your methodology. The developers can run the tests before they open a pull request. They pull a ticket, they write the code to implement the ticket. They go, I'm done. They go, oh, wait a second, new process. I have to run the test cases, the automation first. So they run the automation and something fails. And they go, oh, I am not done. I am not allowed to open a pull request. I have to fix the bug first. So you don't ship bugs into QA. And when it gets to QA, QA doesn't have to run the automation because it's already been run and everything passed. So how can the requirements also be the test cases? Well, we have to write executable requirements. And we have to be able to run the requirements against our implementation, whether that's an API, a website, a mobile app, all three. We have to be able to run the requirements against it. So what are executable requirements? Well, this is an executable Python program. I don't see it executing. It's just sitting there doing nothing. But if we have a Python interpreter, then we can run it. And here is an executable requirement. Given these preconditions, when this event happens, then this is the expected result. And that is exactly the form we are supposed to follow for a test case, isn't it? So our requirement looks amazingly like a requirement. It also looks amazingly like a test case. And the developer reads this when $25 is withdrawn. That's an event that comes to my software, and my software has to handle it. What's the first thing I have to do? I have to test the preconditions. If the preconditions are met, then I must produce the expected result. This given, when, then format is called Gherkin. The first tool for automating requirements written this way is called Cucumber. And a gherkin is a small cucumber. And if you catch me during a break, there's a funny story as to how they got their names, and I can tell you that. Our executable requirement isn't doing anything until we have a requirements interpreter. And when we have a requirements interpreter, we can run that requirement against our implementation. And when we run it, it will either pass or fail. And if the developer made a mistake and our bank account balances can only be 2 digits, this requirement will fail because we won't be able to create the preconditions. And if our developer made a mistake in the SQL query and we can't withdraw money, then our requirement will fail because the when can't happen properly. And if our developer is math challenged and gets an ending balance of $76, our requirement will fail there. And when the developer runs the requirements, the report that comes back, the test report that comes back, is a list of all of the requirements. And every requirement is either green or red. And it's not too tough to figure out what that means. So where do we get a requirements interpreter? Well, we can't. We have to write it. There aren't any open source requirements interpreters that you can go download and use. There is an open source tool, Cucumber, that makes it really easy to write a requirements interpreter. And there are official versions of Cucumber for Ruby, Java, and JavaScript. And for C#, there's a tool called, used to be SpecFlow was the tool to use. Now it's called Wreck and Roll. The original author of SpecFlow forked SpecFlow and created Wreck and Roll. Python is in flux right now. I hope within a few weeks, there's a lot of active work going on Python, and I hope within a few weeks, PyTest BDD will be the tool that I will recommend. When we write the first requirement in a new subject domain, we're going to have to start from scratch on our interpreter. So it's going to take time before we can run even one requirement. We won't be able to deliver this to the developer in sprint, the first sprint, or the second sprint, or the third sprint. But as we build out our interpreter so that it understands more requirements, it becomes easier and easier to add new requirements. And that means it becomes easier and easier to deliver automated tests in sprint. So as we go forward, it gets a lot easier and a lot faster. And we'll see why to some extent. We'll see why. So let's look at a very simple banking requirement. Gherkin says that all requirements are either scenarios or scenario outlines, and they have a title, and the title should always state a business or product rule. So here our product rule is withdrawing money debits the account balance. Pretty simple. And then here's our requirement. Given an account with beginning balance, this thing in angle brackets, we haven't seen that before. That is a parameter that will be filled in from an examples table. We'll see in a moment. And when we withdraw some amount, then the balance will be some ending balance. And here is our examples table. Very easy to understand, and we should always make it easy to understand. Use very simple, obvious patterns in your examples table. We start with $99, we withdraw 10, we should have 89. Now, our requirements interpreter, we write code so that it knows what to do when it sees this. When it sees given an account with a beginning balance, it will go into our back end and create an account with that balance. When our interpreter sees when amount is withdrawn, it will go to our application, whatever interface we're testing, API, website, mobile app, and it will attempt to withdraw this amount. And when it sees then the balance will be, it verifies that the amount left, the remaining balance after that withdrawal, is the expected amount. And if any of those things fail, it fails the requirement, comes back red. When we add another example, though, we have no automation to do. The interpreter already knows how to run all three of these statements. If we need another example, the automation is already done. And as we create more requirements, if we can reuse this same language, this same gherkin, it's already automated. So when we have to write a new requirement that requires, say, one new then statement, but these are reused, we only have a little bit of automation to do. So it becomes easier as we go forward. What happens if we introduce an entirely new concept? Suppose our bank decides to charge transaction fees. So here's our scenario outline. If the account balance is less than $100, withdrawals are charged a $5 transaction fee. Now notice that this business rule is ambiguous. Is $100 before or after the withdrawal, the less than $100 where you get a transaction fee? Doesn't know, don't know, doesn't say. But that would be a very typical narrative requirement. And there you get a bug. But let's look what happens here. Here's our requirement. It's identical to the previous requirement. No difference, which means it'll already run. But the examples are different. Look, we've got a beginning balance of $99. We withdraw 10. We don't have 89, we have 84. There's our transaction fee. And let's look at the next example. $100, withdraw 10, you've got 90. There's the answer to our ambiguity right there. There is no ambiguity at this point. And if a product owner comes back and says, oh, you've got a bug, you were supposed to charge a transaction fee on that transaction, we take the product owner back to the requirement and say, Mr. or Mrs. Product Owner, you wrote this. Is this not what you want? Because there's no ambiguity there. And now we can deliver the automation to the developers not before they finish writing the code. We can deliver it before they start writing the code, because as soon as we write the requirement, we can run it. Again, today, a development project requires multiple documents. We've got the requirements, we've got an architectural design docs, we've got detailed design docs that list additional boundary conditions and corner cases that aren't called out in the narrative requirements. We've got test cases, we've got a requirements traceability matrix. And these are all decoupled. If you make changes in the requirements documents, you have to manually go check these others and see what changes need to be made there. And you know, and I know, we have all worked on projects where that updating did not happen. We've all worked on projects where the code got changed and the requirements never had. And they hand you the documentation on the product and say, here's the documentation, but chapter 5, it's mostly wrong. And the test cases, the product owner's never going to review the test cases. So there's an opportunity for the QA team to have a third viewpoint on what it is we're building and testing. Product owner is not going to know about it. Specification by example has just 2 documents. You've got the requirements documents and you've got the architectural documents. You don't need detailed design documents with additional corner cases and boundary conditions. Specification by example says those should all be listed in the requirements, the examples in the requirements. And it doesn't need test cases because your requirements are your test cases. Why would you spend time writing test cases if you can run your requirement? And you don't need a requirements traceability matrix because you don't need to trace something back to itself. And your test report is a list of all of your requirements, and every requirement is either green or red. So specification by example is not a QA tool. It is not a development tool. It is a product development methodology that begins with the product owner or whoever's writing the requirements, and it is a radical paradigm shift. This is not something you change to in a week. So how can we implement this? Well, we have to have at least 5 things. We have to know how to do this. Not just how to write Gherkin, but how to write good Gherkin. Learning the mechanics of a programming language is not sufficient to make you a good programmer. How many of us wrote really wonderful code the first time we ever wrote code? Not me. We have to have the discipline to keep going when our proof of concept is difficult. And when one of your colleagues says, I've been doing QA for 85 years and I'm an authority and this is stupid. I've never had anyone say 85 years, but I've certainly had people say, this is crazy. I've had people look at me like I had extra holes in my head, trust me. We have to practice. If something is at all complicated, we never, ever do it well the first time. We have to practice. When I teach the class for this, I always say the first time we write Gherkin, We all write bad gherkin. I know because I did. And trust me, in my classes, when we go through, yeah, we all write bad gherkin. We have to have support. This is not something that just the QA team can do. It's a methodology change, and that means organizational change. So we need to have support, preferably from someone who the VP of development or the CIO or someone who the product owners, the developers, and the QAs all report up to. Richard Lawrence, who wrote one of the really, really good books on this methodology, said a BDD transformation that begins in QA will fail unless it quickly becomes a cross-functional initiative. And I teach my students to consistently refer to this as specification by example. Never, ever BDD, and never, ever use the words test case. I once had the manager over the business analyst. I had sent out an email saying the QA team is going to start writing requirements for this project. The business analyst had said it's just a replacement for the existing billing and revenue management system, which was put in place 10 years ago. No one has those requirements, but we're not going to write requirements because the new product just has to do what the old product does. No difference. And I said, okay, but we're going to write requirements. And the manager over the business analyst called me and was very polite, but asked, why are you writing requirements? And I said, well, because we have been told to deliver automation in sprint. And the only way I can do that is to write requirements using this specification by example methodology. And the manager said, are you writing test cases? And I very carefully said, we are writing requirements. But I won't tell you that. We're writing requirements. And the manager over the business analyst assigned, out of those business analysts who had no time whatsoever for doing this, assigned his lead business analyst to assist. And within a month, she was writing the requirements using specification by example methodology and Gherkin. So if we want this to succeed, we have to include a product owner or business analyst or whoever is writing requirements in your company. And changing the language is one of the ways that we do that. We do not write test cases, we write requirements. We never use the term BDD because the product owner will say, awesome, do development any way you like, but don't include me. It doesn't involve me. And we have to have time. BNP Paribas, it took 9 months. Raytheon, it took about the same. In my experience, 6 to 12 months is what it takes to get this instituted, get everybody up to speed, get it very consistent. So every single sprint, you're there with the automation. So I can give you one of those things today. I can give you knowledge. I cannot give you time or support or any of the other things you need, but I can give you some knowledge a little bit. So here's your 2-minute drill. Specification by example says that we must write requirements in this given, when, then format. Given these preconditions, when this event happens, then this is the expected result. And that's Gherkin. And we write a business rule from the user story. So we've seen this one or this one. And we illustrate that business rule with the gherkin. And we illustrate the gherkin with concrete examples. And we've seen this. Here's our user story. Accounting department, I want late bills to be charged a 5% penalty. Business rule, late bills will be charged a 5% penalty. Scenario, given a bill that is 61 days past due, now we have a concrete example. When the total is calculated, then a 5% penalty will be added. And if the developer types less than, where they should have typed less than or equal to, or vice versa, when they run this requirement, it's going to fail. And the QA team will immediately say, okay, so for 60 days, there's no penalty? Right, for 60 days, there's no penalty. And the QA team will then write, given a bill that is 60 days past due, when the total is calculated, then a 0% penalty will be added. Because seeing concrete examples makes it easier for us to think of other examples. And what if they're on a sliding scale? Well, same requirement, except now we have an examples table. So at 60 days, there's no penalty. At 61, we've got our 5% penalty. At 90 days, it's still 5%, but at 91, it's 7%. Product owner can change their mind, write this new requirement. We have no automation to do. It's already automated. And our requirement clearly illustrates all of the boundary conditions. So what's so hard? I mean, this looks pretty straightforward, right? You write given, when, then. And we know how to write test cases, so this should be easy. Well, how many of you have ever created a domain-specific language? Because that's what we're doing here. We're creating a domain-specific language in which we can write requirements specifically for our business. And how many of you have ever written a language interpreter? How many of you think that that will be easy? First time? No, I think not. Creating a domain-specific language is actually pretty easy. I mean, it really is, unless you want it to be a good domain-specific language. Then it's a little harder. And it takes practice. So scenario title should state a business or product rule, does not have to be concrete. We illustrate the title with the gherkin. We illustrate the gherkin with concrete examples. We write the given in the past tense. It is something that happened in the past or conditions that exist now. The when is the action, the event that's taking place. So we write that in the present tense. And the then is the expected result. So we write it in the future tense. We should always be consistent with the language that we use. We never do this, where the change in this is in 3 different places. If we write it this way, given an active, given an expired, given an inactive, it's very, very easy to see what's changing because it's in exactly the same place in every one of these statements. Writing the same thing different ways is probably the single easiest mistake to make. Certainly, it was a mistake I made. Choosing the right language and using it very consistently everywhere, that's the hardest part of this. There's a lot more to know about writing good Gherkin. That's all we have time to cover today. And we haven't even touched on how to automate efficiently. You can also reuse most of your automation across multiple interfaces. API, website, 2 different mobile apps. At General Motors, we took the same requirement and automated it across internal website, external website, API, 2 mobile apps, the infotainment console in the vehicle, and the API behind that, between the car and the back end. And at runtime, we could select which of those 2 interfaces we were going to use to test between. That's flexible. There are some good learning resources available. Before you Google BDD tutorial, please read my blog post titled "Never Google BDD tutorial." There is so much bad advice out there. You can find it there if you like, or you can just Google "Never Google BDD tutorial." Question, Jeff? Jerry, sorry. Yeah, probably Googling cucumber or gherkin tutorial is just as bad. Yes. Thank you. There's some really good resources out there. Of course, my website, cucumber.io. This is the folks who actually wrote Cucumber. They're authoritative. That's where I got trained, ASLAC. Goiko is the guy who wrote the book titled Specification by Example. Great stuff. Specflow.org, great website, got lots of authoritative information. Rec and Roll is the fork of Specflow by the original author of Specflow. And again, great stuff there. Anything linked from these websites, you can trust. Anything not linked from those websites, I don't know. But you can go back to the blog post, Never Google BDD tutorial, and you can look at a website you're looking at or a blog post you're looking at and quickly decide, is this trustworthy or not? Because you'll see the same mistakes time and again. Thank you. Questions?